I want to tell you a story. When we originally had the idea of FrenchKit, we sat down, Mathieu, Nicolas, Michel, and moi, and me. We pardon. And we started thinking about which speakers we would have liked to have here on stage. And the requirements were about people who were really keen on sharing knowledge and on contributing to open source project. So the next speaker, Jesse SQUIRES, has all of these requirements and all these qualities, and he is even more. He's a humble person, and he made great open source stuff like just Q messages to the controller, and also he creates one great tool for all of us, which is the Swift Weekly Brief, which translates and redacts all what's happening in Swift, in the mailing list of Swift. And when we talked about this conference, he had many ideas, many proposals, and then a while ago he told us, I have a better idea for you, is to go through all the proposals, the 140 proposals of Swift in 30 minutes. And we loved the idea, and so Jesse is here on stage to talk about 140 Swift proposals in 30 minutes. So please welcome on stage Jesse SQUIRES.
Hey everyone, I'm Jesse. So today we're going to be talking about Swift evolution and all of the proposals. And so like Swift itself, as I was writing this talk, it evolved as I was writing it and coming up with these new ideas. I had a lot of questions about the proposals that I couldn't answer. And I'll talk a bit more about that as we go through. So this talk has changed a little bit, and we're not going to be going through every single proposal, but kind of doing an analysis. So, if you're not familiar with Swift evolution, this is the process by which we, the community and the core team, collaborate on Swift for changing Swift, adding features, removing features, fixing bugs. Swift evolution really represents the openness of Swift. And the primary purpose is to engage the community. The core team wants to make Swift better. They want it to work for all of us. Most of the core team, they're systems programmers, they are compiler engineers, they're not app developers like us. And so while they have a good idea of our needs, it's helpful if we share our feedback on the tools that we need to build great apps. The other primary goal of the Swift evolution process is to maintain the vision and conceptual coherence for Swift. We often refer to code as being Swifty or not, and that's really what this is about. And ultimately, the core team is responsible for the strategic direction of Swift. So really what this means is we want to take all of our ideas and turn them into improvements. And anyone can participate in this process to make Swift great again. So we've had Swift for 2 years now. It's only been open source for about 1 year, and 3.0 was released last week. So today we're going to talk about how we got there. And so like I mentioned earlier, my original idea for this talk was kind of a lightning talk going through all these proposals, but then I had questions like, how many authors are there? I wanted to ask things like, what are all the proposals written by Chris Latner, authored or co-authored? And you can't really do this now. All of these proposals are publicly available on GitHub, but they're just markdown files, so just plain text. There's no way to really query or filter this data. So I wrote some scripts in Swift, not Bash. And basically what happens with this project is it generates a playground with all of the proposals. So it fetches all of these proposals from the Swift Evolution repo, and you basically end up with this structured data. You get an array of these proposal types that contain the metadata as well as like the raw file contents. And I'll be posting all this code on GitHub after the talk. Today we're going to be looking mostly at kind of this metadata to see what we can learn. But it's not just metadata. We can learn some interesting things by aggregating these different statistics. But in the future, we could actually do like a much more sophisticated analysis of these, like maybe some kind of linguistic analysis. All the tools are kind of there in this project. So, as you know, we have 140 proposals since Swift was open sourced. It's a pretty small data set, but so it's kind of hard to draw too many conclusions, but we can still see what we can find. So this is the breakdown of those. 98 have been implemented. The 10 accepted proposals are ones that did not make it into Swift 3, so they'll be in like Swift 3.1 or some other future release. And then we have the deferred, rejected, and withdrawn proposals. But this means that the acceptance rate is 77%. That means over 3/4 of every proposal written and submitted has been accepted, and 70% were implemented for Swift 3. So not too bad considering how many there were. We can look at word counts. So like on average, a proposal is almost 1,200 words. The longest proposal was over 7,000, and the shortest proposal was less than 200. Usually word count is maybe not a useful metric, but we have a very targeted, focused set of data here. We know all these proposals are about making changes to Swift, so it can kind of give us this general idea of complexity. And there's a huge range here. I mean, if a proposal takes over 7,000 words to explain the change, it's probably pretty big as compared to something less than 200 words. Next, we can look at like word or topic frequency. If you've been keeping up with the proposals, we're making tons of API changes, so it shouldn't be too surprising that we mention APIs a lot. We're mentioning Objective-C and bridging quite a lot in all of these proposals. That's a very common theme, and we'll talk about that a little bit more. But since we have the raw file contents of all of these proposals available, we can do all kinds of searches. I think what will be most interesting is seeing in Swift 4.0 and 5.0 if we're still talking about Objective-C and bridging as much as we are now. And finally, just for fun, I wanted to see how often we mentioned Swifty in these proposals, and only 6 times across all 140. Okay, and so behind all of these proposals is an author, or sometimes more than one. And so there's 78 unique authors across all of these proposals. It's most common to have a single author, so the majority, 100, have a single author. There are 30 proposals with 2 authors, and so on, and this gives us an average of 1.8 almost authors per proposal. The 9-author proposal, I believe, was also the 7,000-word proposal. We can also look at top authors. So Erica Zadoun has authored or co-authored 25 proposals. I knew she had written a lot, but I didn't realize it was that much. And it's actually the same as Doug Greger and Joe Groff combined at the number 2 and 3 slot. So one thing that's interesting here is that the top proposal author does not work at Apple. The next 4 are core team members. And one last note here, this does not mean accepted proposals. This is just authored or co-authored. So for example, Joe Groff hasn't had 12 proposals accepted. Some were deferred or rejected. But total, he authored or co-authored 12. Okay, and now with all this data, we know that which version of Swift these proposals were implemented in, so we can see how Swift has evolved through each version. And so with 1.0 to 2.1, there were no proposals because Swift was not open source yet. In 2.2, 8 proposals were implemented. 2.2 was in development for about 3 to 4 months. And when Swift 3.0 came along, 89 proposals were implemented in about 5 to 6 months. So that's 11 times more, or a 1,000% increase. So that brings us to Swift 3.0, which is 1,000% more Swifty. And really, these proposals have defined and refined what Swifty really means as the language matures. And so we can look at the original goals for Swift 3. The big one was ABI stability and resilience, portability, type system cleanup in docs, cleaning up the documentation, completing generics, focusing and refining the language in general, and then developing the API design guidelines. So for API stability, this is finalizing runtime data structures and calling conventions and things like this so that future code can interact with older binaries, basically. So not all of these goals made it into Swift 3. There were so many proposals. What actually happened? Well, nothing compiles. Because the only thing that changed about Swift 3 is everything. And this is because there's overwhelming community participation and feedback. Remember, 3 out of every 4 proposals were accepted, and 140 total. And there were basically 5 common themes or 5 types of proposals. We had syntax refinements, which is things like moving the where clause for constraining generic parameters or refining function parameter labels. We had API improvements and redesigns like the collection indices redesign. There were lots of bridging proposals to improve the interop with ObjectiveC and Swift. New features like property behaviors and the different access control proposals, which we'll talk about later. And finally, there were bug fix proposals. These are kind of somewhere in between like an API improvement and a feature where the compiler was designed a certain way, and as a result, you had these different side effects. And so these proposals were kind of considered like bug fixes. And so the Swift evolution process didn't necessarily contribute to all of those goals, and it actually changed those goals and kind of informed the entire development process. And so we ended up with kind of a refinement of some of the goals and the addition of some others. And so primarily, there was a strong focus on the API design guidelines with automatically importing the Objective-C APIs and having this Swiftification of Objective-C, and then adopting the new naming guidelines for the standard library and other Swift APIs. Still focusing and refining the language. The text in black here are previous goals that remained. New goal was to improve the tooling quality, especially with Swift 1.0. The tooling was very immature and difficult to deal with. And finally, all of this kind of wraps up into this idea of source stability. So we have this big migration for Swift 3, and all of there are many syntax changes and API changes. And the goal is to hopefully not have to do that too much more after Swift 3. And now I've selected a few proposals to kind of talk about a little bit more. And there are quite a few that I think are pretty important, but we only have so much time. So Proposal 5. Which was the better translation of Objective-C APIs into Swift, or make Objective-C APIs great again. There's this example here. The old Objective-C APIs are very verbose and often redundant with the terminology and the types. So the goal of this proposal was to refine that, make this more Swifty, less verbose, and a lot cleaner. So you can see after we still have the same API, but it's much easier to read. This is pretty impactful because it affects pretty much all of your code. Every line of code is going to change because of this proposal. Next was Proposal 23. So make Swift APIs great again, the great API transformation. So here, the core team worked pretty hard on coming up with these very nice, very clear guidelines on how to name APIs. So in this example, to sort this array.sort, that sorts it in place. It's the present tense of the verb, so it's modifying that array there. And to return a new sorted array and leave the original array alone, we have sorted, which is the past tense and returns a new array. So there are many different changes like this that help kind of clarify exactly what these APIs do, and the guidelines lay out very nicely kind of how you should structure these. Next was scoped access level, Proposal 25. So originally, the earlier versions of Swift just had 3 access control specifiers. There's public, internal, and private. And public meant it was publicly available outside the current module. internal, it's only visible within the current module or framework. And private was private to that file. After this change, private became file private, and a new private keyword was introduced to restrict the visibility to the current scope. This has a moderate impact on your code. I think one of the major downsides to this proposal is that if you define a class with private properties, and then you want to create an extension on that class, that extension is now in a new scope, and you can't access those private properties, and so they have to become file private. I'm not a huge fan of this change. We can talk more about that in a couple slides. And similarly, there was proposal 117, which had a lot of debate on the mailing list. This actually went through 3, I think, revisions in different review periods because there's so much feedback from the community. So the title of this, allowing distinguishing between public access and public overridability. But to remember, you can just think, make subclassing great again. And basically, this prevents subclassing by default from outside of a framework. So before, you would declare a class, let's say you have a view controller that's public. Before this change, you could subclass that view controller and override any of the methods. After this change, outside of that framework, you can no longer subclass or override methods unless they were marked as open. So open means public and subclassable or public and overridable. And so that brings us to access control in Swift 3, which is now much more complicated. We have open, public, internal, file private, and private. I prefer the simpler model with only 3 specifiers. I don't find much value in open as an open source author and framework maintainer. It's not something that I've ever felt like I needed to use. I would just use public or make things final to prevent overriding or subclassing. But this is the model that we have today. Next, we'll talk about 69, which was mutability and foundation value types. So this proposal really focused on making foundation more Swift-friendly and more natural to use from Swift. So before, if you had an NSDate, it would be, NSDate was a reference type, so now we have this new date value type. When date was a reference type, let and var didn't really have any effect. But after this change, you can have a date variable and you can add a time interval. In this case, if you declare it as let, so it's a constant, then you'll get an error if you try to mutate that. So it makes these APIs much nicer to use. And another good thing about this proposal is that we get a big performance increase in a lot of cases. So for example, with NSDate, it's really just a double. So when that becomes a value type, we no longer have the reference semantics. We don't have to do reference counting. And so there's a lot less overhead for the compiler. And proposal 65, this was the collection and indices redesign. Before, index traversal was the responsibility of the index. So you would have something like index.successor. After this change, we have a much more natural use of Indices, where it's actually on the collection itself. So it's much nicer and more intuitive, I think, to operate on the collection instead of the index. There are also some performance benefits here because the index before, in some cases, had to have either implicit or explicit knowledge about the structure of the collection. Now the model is much simpler. And a more recent proposal was 116, which changed how ObjectiveC ID is imported into Swift. So if we had a method like isEqual, before it would be imported as any object, which is a reference type, so any class, any object. And after, this would be imported as any, which could be a value type. So it could be an enum or a struct. This was a pretty impactful proposal because it allows a more natural use of Objective-C interfaces in Swift. It doesn't impose that you have to use reference types in Swift. And as you know, Swift is very heavily focused on using value types and avoiding reference types. And so this was a good change. A few proposals came after this to kind of fix some bugs because now with this change, in some cases, you have to do some different casting between any and any object, kind of depending on the context. But these follow-up proposals resolved a lot of those issues. And finally, I want to talk a bit about the cost of Swift evolution. So, as you know, every change in software is a trade-off, right? The cost of the change that we make now is foregoing the next best change that we could have made. Or in other words, this is the opportunity cost. And so implicit in what did we gain by making these changes is what did we give up? And the answer to that is most of Swift 3's original goals. So we didn't stabilize the API, generics are still not finished. But this was the first major open source release. 2.2 was the first minor open source release. But Swift still had a lot of rough edges. And all of these proposals pointed out syntax inconsistencies or behavior inconsistencies. What comes to mind is all of Erica Sadoun's proposals. Most of her proposals were refining weird or inconsistent syntax. And really, the entire open sourcing of Swift, we were in this kind of novelty effect stage where everything was very new. Everyone wanted to participate and get involved. There's tons of traffic on the mailing lists, and that's kind of what led to this big change in goals. And so we can ask ourselves if that trade-off was worth it. Looking back, I think maybe some of the proposals we could have put off until later. But overall, I think Swift is in a much better place now than it was. There's still quite a bit of work to do, but we're mostly source stable. There might be a few more source breaking changes coming, but they should be pretty minor. Hopefully no more expensive, painful migrations, but interop with Objective-C is much better now. And probably most importantly, the community learned about the Swift evolution process. We know what to expect now. We know how this process works. We know how to submit and review proposals. And that's all I have.
Thank you. So at some point you said that the people who are actually writing Swift are mostly system developers and compiler engineers. Mm-hmm. And you said that it's very interesting for them to have the point of view of some app developers, some kind of real users of the language. And it's really interesting because it's also seems that the guys who are actually implementing the proposals are not the same as the one who are actually doing the proposals. What can explain that?
Yeah, so many of the proposals were, from community members, app developers, and a lot of people don't have experience with compilers. So it can be a pretty complex topic, and it's also, Swift is a very large project, so it's kind of hard to get involved or to wrap your head around all the different pieces. And so very often you would have someone saying, this is a feature I want. I've seen this in another programming language. I would like it to be in Swift. And there's a debate, and they help write the proposal. And sometimes someone from the core team will come in and help with more of the technical details.
Yeah, that's something also that is kind of scary. Like when you want to get involved and you see that on most of the proposals, there are some kind of quite deep details on how to implement that. It's kind of frightening, but is it like needed, or like can you be helped?
Yeah, so everyone on the core team is super nice. They want to help you get involved. If there's a proposal with this idea and you need help on the technical side, so if you don't know, like the proposal should actually have the kind of technical specification of how something should be implemented. And so if you don't have all the skills for that, there's always someone ready to help.
Okay,
great. Yeah, I had another question actually. Question that I always hear, and I too often hear actually. So let's say your boss told us that you couldn't have Swift because it's moving too fast. What would you say?
I think before Swift 3, that's a pretty good argument. There were lots and lots of changes. I think if anyone had code before Swift 3, you definitely felt the pain with migrating to Swift 3 because so many things broke. It personally took me a couple weeks to get everything switched over and like make sure it still worked. So I think now that Swift 3 is out, I think that argument is much weaker, and I think Swift is much more stable. The core team has been very clear about preventing source breaking changes, and so I think if you were waiting to adopt Swift 3, now is the time to do it.
Okay, so you wouldn't have quit your job.
Right.
And about like the path, it seems that all those proposals are actually increasing, and it's getting faster and faster. And how do you actually get the time to follow all that and to even provide some kind of summary tools for us to be able to follow that? I mean, what's your secret?
Yeah, there's no secret actually. I follow the repos on GitHub. I kind of
but that's huge, and it's
that's true.
How much time do you spend every week?
Every week, maybe a few hours or more. I will do a little bit each day, and there's actually some people from the community help with the newsletter now. So if you're interested in that, everything is on GitHub, and the newsletter we publish with Jekyll, so it's just kind of writing some markdown. So if you have anything that you want to contribute, you can just submit a pull request, and we can include that in the newsletter.
And if you wanted to become an actual active contributor, do you need to spend like a lot of time, like every week, follow everything, or can you jump in? And how would you jump in. Like I'm just a regular Swift user. I don't follow the Swift evolutions, mailing list, or all what's going on. Is it possible for me to actually write a proposal? Is it viable?
Yeah, I think so. There are a lot of examples with all the previous proposals that you can look at and kind of get an idea for how a proposal is written. I would spend some time on the list if there's a change that you want, a proposal that you want to make. Spend some time on the list, and you can kind of send an email and pitch your idea and see if other people like the idea.
Or like pitching before like implementing the real, like writing the real proposal.
Exactly, yeah. So kind of, develop your ideas enough to explain them on the mailing list, and then afterward, hopefully, some people will be interested in.
And it's not going to be seen as noise on the mailing list. Like,
no, definitely,
okay.
definitely not.
Nice
yeah,
to. And
what I actually like very much about Swift Brief is that sometimes you introduce some modifications that can be made to the Swift source code, and the easiest modifications that can help people get on board and contribute to Swift. And I think it's a great idea.
Thanks.
Just one last question, maybe, is about that really strange person, Erika Sadoun. Like, did you meet her?
I've never.
Is she real?
Yeah, I've never met her in person. I only know her through Twitter and GitHub. So I know she lives in Colorado, I think. And
that's what they want you to believe.
right.
Okay, let's move on to the next speaker. And thank you very much, Jesse.
Yeah, thank you.